Hi, welcome to another video of machine learning course. So I guess you have a quite a bit understanding of basic machine learning approach and so in this video I will go through the necessary steps to build and deploy a machine learning project or application. Okay. So this starts from basically data collection to data deployment, model deployment, and in general, if anyone in machine learning domain or any machine learning engineer or data scientist has to go through these eight basic steps for end-to-end implementation of any machine learning project. And so these steps are basically the first is the there's the framing the problem and look at a bigger picture. Second step is getting the data and discover and visualize the data on to gain some more insights of your data and prepare the data before the to fit into the machine learning model or algorithm. Okay, and fifth step is explore different models and shortlist the best one, and fifth one is to fine tune your models and combine them for a greater or better solution. Okay. Sorry. So present first, and then you have to present your solution, and in the final step, once your final model is ready, you can launch, monitor, and maintain your system. And I think it requires quite a bit of time to discuss these points one by one. So I splitted the topics in 3 parts, and in this video I will discuss the first 4 steps. Okay, so let's proceed to the first step, that is framing the problem. Okay, so once you are assigned with a new project by your supervisor or mentor, you must understand that what exactly the objective of the project is. Okay, because building a machine learning model, is not probably your ultimate goal, right? How does the community expect to use and benefit from this model? That is also important, and knowing the objective is important because it will determine how you frame the problem and which algorithms you should select and which performance measure you will use to evaluate your model, okay, for the given task. Okay, and how much effort you will spend into tweaking it. Okay, so these are very important before starting any project. And um, and once you have understand this basic you have the answer of these basic questions, you must be you need to frame the problem as either as a supervised or unsupervised or task, or either you can apply reinforcement learning, right? And then whether you have to understand whether it is a classification task, whether it is a regression task, and should you use batch learning or online learning technique, okay, which is more convenient for this task. Okay, and once you understand that whether it is a classification task, then also you have to understand what type of classification. This is a binary classification, or whether it is a multi-class classification or multi-level classification or multi-output classification. Okay, there are varieties of tasks that usually machine learning engineers are approach. So if it is a regression problem, then you have to identify whether it is a univariate regression or it is a multivariate regression problem. Okay, so these are all important. So to start, because this answer will help you to decide what strategy, what model you should adopt for in the next steps. Okay, and finally you have to have a very good understanding about your assumptions. Okay, what are the assumption you have taken to build the model, or build the model, because it is good practice to jot down and verify this assumption, because once when your model is ready to use, you must have a clear idea that when your model is supposed to fail to predict, okay, something, and if any one of the assumption is not met, okay, any assumption is not made, then your model is supposed to fail, right? And you have to you should have a clear idea about these things, and when your model will not be able to perform. Okay, so with this basic understanding, you can now start your project and you can proceed to the next step. And obviously the next step is getting the data. Okay, because without data there is no machine learning, right? So without data there is no machine learning. So obviously when you think about data, many questions may emerge, right? So where from you will where is your data, where from you collect your data, how much data do you really need for any project? So this all questions are important. Okay, so okay, so where from the real data can be collected, and it is obviously it is required that you should deal with real data rather than artificial data sets. And usually the data is provided by your project mentor or some database application manager, but often we there is another option is the third party service provider. And 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 we have so many open data sets for ranging across different domains, and here are some few places you can look to get data. And these are some popular data repository, free data repository, open data repositories that you can use. These three are very popular, that is Kaggle datasets, UCI machine learning repository, and Amazon datasets. Okay, so there are plenty of datasets are there in different domains, and you can use them. So now the question is okay, so how much data, do you really need? Okay, so this is an interesting question, but it has no definite answer, because how much data you need depends on how many features there are in the data set. Okay, so rule, but it is recommended, or it is rule of thumb is to collect as much as possible, collect as much as data possible, because if you look at the performance versus the amount of data graph of standard machine learning algorithm, you will see that for small amount of data, the classical machine learning models and large neural network or deep neural network or medium sized neural network all performs the same. Okay, there is no almost their performance is same, and right, but when you will use more amount of data, you will see that the large neural network or deep neural network starts to take off other models, and that is the merit of deep learning, and why this is and the big data and deep learning are together at creating the remarkable things nowadays, and that's why the deep learning is taking off nowadays. Okay, but it requires, but lots of data also requires hardware optimized algorithms. So that is one point that you have to deal with. Okay, so it is obvious. So for any machine learning algorithm, the rule of thumb is to collect and use as much as data possible. Okay, so next point is that how you will next point is the data visualization to get some more insights of your data. Suppose here I am giving an examples where your raw data is basically is audio files or speech files. So we can plot this data, or we can visualize the data in time domain as well as in frequency domain by Fourier transform. Okay. So this is time domain representation, this is frequency domain representation, and from this representation you can identify, or you can answer, you can understand whether this, suppose the silence removal is required or not, whether there is any silent segment is there within this speech files is there or not. So then you should remove those silence parts for your application. And you can also understand what are the audio length, each of the file, what is the audio length. If you visualize the data, then you can understand whether each file, each data point are having the same length of audio or not. You can also understand from this visualization that whether these are noisy or noise free audio files, whether you should use some noise reduction algorithm before feed this data into your model. So this type of answers, this type of answer of this type of questions could be answered if you visualize the data, and you will get more insights about your data. Okay. So next step is prepare your data to feed it into the machine learning model. Okay. So usually we came across two different types of data set. One is structured data set and another is unstructured data set. Okay. So in structured data set, we usually the data given in table format, row column format, are in comma separated numbers. Okay. So this is structured data set, and in unstructured data set is quite raw data. So suppose audio, image, video files, some text files, some media files is given to you. Okay. And you need to have a different strategy for different types of data set. Okay. For structured data set, you usually start with data cleaning procedure, because in structured data set you will see that there will be so many missing values in your data set. So you should, to get rid of this missing values, you should use some data cleaning procedures. And then in structured data set, one advantage is that the attributes or features are quite straightforward, and you can understand from the tables that this is my attribute that I should use. And you can also experiment with different attribute combination, and it may you may see that some combination may be effective for your machine learning algorithm or machine learning model. And finally you will feature selection and you will do feature scaling. So this all steps are basically your data preparation steps, and before feeding the data into the model. Okay. So similarly in unstructured data set, the data cleaning is usually not used so much, but it may require some data cleaning may be required if there is some outliers data is there. That is not it is not good to have outliers data which is for machine learning. So you may need to do some data cleaning in unstructured data set also. And obviously, but the feature extraction process is not very straightforward in unstructured data set. You should have a very good domain knowledge. Suppose you are working in audio processing, you should have a very good understanding of audio and audio features. What audio features and traits are you going to use, that you should have a clear idea. If you are working in image processing, you should have a very good domain knowledge of images. Okay. So it is not very feature extraction. It's not very straightforward for classical machine learning algorithm for unstructured data set. Okay. And similarly, you then after feature extraction, you should employ a feature selection and feature scaling. Okay. Sometimes we just skip this feature selection step, and we apply this feature selection step for our for our best model, and before that we just follow the feature extraction and feature scaling steps. Okay, we don't apply any feature selection, and when you get the final model, final best model, you apply feature selection and you get the you use this all these steps. So this is called basically the feature engineering in machine learning. Okay, and and it is very important to start with any machine learning algorithm. You should do these steps very carefully so that you should not get any problem in later stage of your algorithm implementation. Okay, so here I will give some example of feature extraction from audio. Suppose audio speech is a unstructured data, right? So in unstructured data, you need to have a very good knowledge of features, domain knowledge. So here, usually in classical machine learning algorithms, we usually apply the Mills power spectrogram or MFCC features. Okay, so MFCC is Mill spectrum, Mill frequencies, captures coefficients. So these are usually used for to train the machine learning model. And but in deep learning area, usually from the raw data, the raw features are used. So the spectrogram is usually used. So this is one example that how you can extract the features from the raw data. So for unstructured data, you need to have a very good domain knowledge to extract the features. Okay, so in every domain you should have a good understanding of about your raw data. Okay, whether it is audio, speech, or something else. Okay, audio, speech, or image, or text files, everything. So anything. So let's proceed to the next step, that is feature scaling. Okay, so this is also very important step, this features transformation or feature scaling. So we have often see that after feature extraction, different features have different ranges and statistical distribution. Okay, and it actually it creates problem to train your machine learning model. And one solution of this is to normalize the features so that it will speed up the training process. And this feature scaling should be applied to everything, the training, development set, and testing set, for everything. But target values don't need any normalization. Okay, only the features should be normalized. And basically there are two methods are usually used, that is min-max scaling and standardization. Both are included in scikit-learn library. Okay, min-max scaling and standardization. I'm not going into the detailed step. You can explore it, or you can discuss later on. So, okay, so but usually this min-max scaling and standardization is used, and it requires the steps to calculate the mean and variance of each features. Okay, when you apply this methods. But in scikit-learn, you basically simply use a function to implement this thing. Okay, so that's all. So next thing is that feature selection methods. Okay, so once you get the all your feature set ready, the feature selection method is basically eliminates the irrelevant features and only keep the relevant features to train your machine learning model. Okay, so here the main advantage of feature selection is that it improves the model performance. Okay, when you have irrelevant features in your data, this feature acts as a noise which makes the machine learning models perform very poorly. Okay, and it also feature selection also avoids sometimes the overfitting, and it increases the more generalization. Okay, so that's why the feature selection is often done in machine learning project. Okay, but don't mix it up, or don't confuse this thing, with the dimensionality reduction in machine learning, where usually the principal component analysis is used, but it's sometimes the feature selection is mistaken with dimensionality reduction method, but this both things are completely different. Okay, so feature selection is basically what it does, that from a set of features, all features, it selects some best features, and then this best features is applied to machine learning model to um, and then we evaluate the model. Okay, so in scikit-learn different methods are available for feature selection, and this all are statistical methods. So one is univariate feature selection method, and recursive feature elimination method, recursive feature elimination with cross validations. And these three are very popular feature selection methods that often the machine learning engineers are used. So that's all for now, because I just discuss the steps up to the feature engineering feature selection method. The first four steps of our checklist, that frame the problem, getting the data, and discovering visualization of the data, and prepare the data for machine learning algorithm. So first four steps I've discussed in this video, and up to this, in the next video I will discuss how to select the best machine learning model, how to evaluate the model, and what is the performance measure we can use. And with this so that's all for now, and thank you for watching the video. And if you have any question, please drop it into the comment section. I will try to answer your query. Okay, thank you very much.